Hello to everybody. I will speak on thermal atmospheric tides and on the possibility of a locking of the length of the day during the Precambrian. This is the work that has been submitted and you can access the paper on arXiv. In last year, we presented the first coherent scenario for the tidal evolution of the Earth-Moon system. When I mean a coherent scenario, I mean a scenario that fits very well the present recession of the Moon, which is measured very accurately with laser ranging, and the age of the Moon. And that was the first model to do that. And not only it did that, but it did it without taking into account any geological data. But at the end, when you compare the model to the most reliable geological data, you find a very good agreement. So we are quite confident about this model. The geological data are the tidal rhythmites in yellow and the cyclostratigraphic data in blue. And we consider that the cyclostratigraphic data are the most reliable geological data for this consideration now. That was last year, but since then there have been new data published, and the new data are also in very good agreement with our model. So we could consider that it was done, it was over. But it was not the case. There was something that came out this summer. And it is about a possibility of the day length locking during the Precambrian. This is an old idea that started in 1987, proposed by Zanley and Walker. And in fact, it was at a time where there was no model for this, no good model for Earth-Moon evolution. They propose that thermal tides could counteract the solid tide. Solid tide slow down the Earth, and atmospheric tide has an opposite effect. The bulge is not in the same direction, and it has an accelerating effect on the rotation of the Earth. So the idea is that in the past, the solid tide were of smaller amplitude, and there is a possibility of resonance in the atmospheric tide. So the idea is that this resonance could counterbalance the solid tides. And this model was recently revised by Bartlett and Stevenson. And you see, so you have the length of the day evolution, and you have this plateau. So that was the model of Zanley and Walker, and the model of Bartlett and Stevenson looked to various possibilities in order to fit to the data. And during this summer, there was the first paper published in June in Nature Geoscience, and this paper by Mitchell and Kirchner look again to, it's mostly a geological paper. It looks to all the geological data and look to the various trends for the evolution of length of the day, and they found that here during between 1 and 2 billion years there is a plateau. But let us look to our model. Our model is here. It fits also quite well all the data, but not this one. But what are these ones here? These ones are Panella stromatolite data. And the stromatolite data are not very reliable. Even from Panella itself, it says that the major drawback of stromatolite is the incompleteness of their sequence, which means that they usually find they are missing layers. So the length of the day they find should be, the real length of the day should be smaller than the evaluation. But this was not all. In July, there was another paper in Science Advance this time, stating about the same thing with a model which was using GCM at some point, but on the other hand, very empirical for some parts. this model again advocates for a locking of the length of the day during the Precambrian. The model is in black here. And if you look to our model, I put it here, you see that our model fits much better the cyclostratigraphic data. These data are tidal light data that we don't think is very reliable. And the most important constraint of this model by Wu et al. Is this point here and this point what are there. They are again the data of Panella. So the stromatolite data again. And if you look here, for example, you see that these are cyclostratigraphic data. Our model fits very well the cyclostratigraphic data, and this other model doesn't fit them. So you see that all of these models that look and advocate for locking of the length of the day relies on this stromatolite data. And moreover, and that was just presented by Mohammad, our theoretical studies show that, in fact, most probably the thermal tide, even in the resonance, were never strong enough to compensate for the Earth tide. So the conclusion is that first, there is no need for an atmospheric tidal lock. There is all the data are fitted very well by our model. The model of Wu et al. Is not really a theoretical model. It's a piece of theoretical model, but there are lots of empirical parameters. I have not detailed that here. There are 16 empirical parameters. It doesn't fit the most reliable data, which are the cyclostratigraphic data, and they rely heavily on unreliable stromatolite data. And a conclusion also is that people should again search for more cyclostratigraphic data in the interval of 1 billion years to 2 billion years. We have to continue on this work and to try to settle definitely what is the real evolution, the real tidal evolution of the Earth-Moon system and the evolution of the length of the day. Thank you.